Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hello, welcome to Astronomy Live. Tonight, we're going to take another look at the supernova in galaxy M101. Right now, I'm just double-checking the focus of the telescope using alkaid, which is the bright star you see here, and a Batinov mask, which creates the diffraction spikes you see here. So I'm going to slew the telescope over to galaxy M101, and we'll take a look for the supernova. Alright, let's see what we got. Alright, I'm going to do like a 5-second exposure at 2x2 binning. This will eliminate the color data for enhanced sensitivity. Also cuts the resolution in half. Oh, I see, I forgot to take off the focusing mask. There we go, that's better. Okay. Much better. The galaxy is that little fuzzy thing in the top right corner, so I'm going to grab the hand controller and move it on down. Let's see what we can do here. So I went to 3x3 binning for even more sensitivity, so I can do slightly shorter exposures and still get roughly the same amount of light on each pixel. Try to center that galaxy up here. And try to get it relatively close to the orientation we had a little over a week ago when I last did a live stream, so that ultimately I can combine tonight's images with the previous night's images for a really good image of the galaxy. I mean, astrophotographers who have more patience than I will go for 30, 40 hours or more on a single object over multiple nights to get the best quality image by collecting light over a very long period of time, because these objects are very, very dim. Okay, so let me bump it down a little more. Try to get the core of that galaxy as centered as I can. Okay, now let's take a shot with the autoguider and see if we can get the same guide star in that we had before. Okay, I don't see it at the moment. That's unfortunate. Now let's take a look at the image that we had last time. So this was the final image from the last webcast I did on this object. this was 2 hours, 30 minutes worth of light collected. So what I'm seeing here is the position was similar, but maybe the galaxy was a little further down. So I'm going to try to replicate that here. Okay, that might have been a little much. A little much. Okay. Okay, that's about where I want it. Now let's see if we can find something in the autoguider. There we go. That's what I want to see. Okay, so that star right there in the top of the autoguider window, that's what I want. Now, that's the guide star I had last time, but last time it was in the top right of the autoguider window, so we're going to do some fine adjustment, slower motion of the telescope, and I'm going to use the autoguide rate on the telescope to see if I can move that star to the top right of the autoguider window. Now, in theory, I've already calibrated the autoguider before I moved over here, so last time I did this, I had forgotten to calibrate before I reached this part, which I normally like to do beforehand. Okay. Let's see what that does for the position of the galaxy. Okay, that's too far over. So we'll come back to the west. That bright star was just peeking on the right side of the image in the last image we took, so we want to replicate that. Oh, there it is, just a little more. Just a little more. So if you look again, that bright star right at the right side of the image, we want that in there to kind of fully replicate what we had before. And that's what we got. Okay, so that looks good. Now let's take a fresh shot with the autoguider. Okay. And let's try autoguiding. So this is with the adaptive optics unit attached. This is a tilt-tip mirror system that will keep that star centered using 0.6 second exposures. And honestly, I could get away with even faster exposures. We can go down to 0.5 seconds. We still got good signal-to-noise ratio. That looks good. So, I'm going to set up on autosave. We're going to save these pictures. Now we're going to set this to 1:1 binning for full resolution, full color. We're going to take 5-minute exposures with an auto dark. And let's begin. Okay, so we're cooking away on our first picture. Camera temperature is at -5 degrees. Now that is different than the last time I did M101. My desiccant was no good, and I was getting ice crystals forming on the CCD, so I had to warm it up to 2 degrees Celsius. But now we're at -5 degrees Celsius on a warm Florida night, and that will reduce the noise of the imager and result in hopefully an even better picture this time. How late is the stream running tonight? We'll see. I do have things I need to do tomorrow, but I anticipate I'll go past midnight on this. Bit hazy here. Yeah, we've got a controlled burn not far from my house tonight, so that was putting off a lot of smoke, though it wasn't directly over my house. But I am noticing from streetlights in the distance that there's more haze than normal, more smoke than normal in the atmosphere, that's for sure. Hopefully that doesn't degrade the image quality too much, but that will impact the transparency a little bit. So, we'll just have to deal with it. Also, all the music tonight brought to you by Stellar Drone. Can't remember if I had that. Yeah, I did have that in the video description. That's good. So let me tweet out the stream and get this advertised. Give me just a second here. Alright, that should get some folks in here. Another 87 seconds on the current 5-minute exposure. Now, after it takes this exposure, we're going to see a lot of colorful pixels from hot pixels on the camera. Basically, every camera has them. They're just defective pixels that are permanently on, pretty much. You do get some new hot pixels forming, generally, over the course of the night. But for the most part, they're stable. And so what it's going to do is close the shutter and take another photo with the shutter closed to do an automatic dark subtraction. And that will eliminate the hot pixels from all future pictures that we take. So it'll take a 5-minute exposure with the shutter closed and to use that as a calibration frame. Now, I will say that the proper way to do things is to actually build up a library of dark images. And you can even do that during the day. Just leave the camera laying around with the shutter closed and take a whole bunch of 5-minute exposures. Very important that the camera is set to the same temperature. And that's one of the advantages of having a camera with thermoelectric cooling. It can hold a set temperature set point, and you can guarantee that all your pictures are at the same temperature, because thermal noise is a critical component, and you want to calibrate for that as well. So you want all the pictures at the same temperature. So here comes our first picture. Downloading from the camera now. Beautiful. Okay. So you can clearly see the spiral galaxy here, despite all the hot pixels, and you can see the supernova is right here. I don't know if you can see my cursor. I'll put a cursor on the supernova here in just a second. Let's get things reoriented here a little bit. Nope, not the right marker. There's the marker I had. There we go. There's our supernova. Still looking very bright. Oh, sorry about that, Sassafras. You've got different sort of smoke in your area, apparently. Guess you're up in the northeast. Get some of that Canadian smoke. Yeah, I thought down here in Florida I'd be safe from it, but wouldn't you know it, they decided to do a controlled burn today, so no help there. A couple other things I want to point out that you might notice, especially once the dark frame gets subtracted here in another 2 minutes. There are a couple of dust motes on the CCD. You'll see them as donut shapes here and here. You might see some other donuts elsewhere in the image like that. And those are known to be dust motes on the CCD. Those will be subtracted out of the final image by using flat field calibration frames. So, for full transparency, the proper way to do things is not how I'm going to be doing them tonight with the auto dark feature on CCD Soft. I would not recommend using this unless you're me, because you really want to be able to calibrate these using a library of dark frames, not just a single dark frame. But I'm deliberately doing it this way because it's better for live streaming. It allows us to see the images in real time with at least one dark frame subtracted, so you don't have all these nasty hot pixels in the way, and it makes it easier to see the final image, or at least the live current image. But that is a far inferior way to calibrate the image. It would be much better if I used a library of darks, but in order to do that with this program, I would have to leave it completely uncalibrated. I could not use the auto dark feature because it will not save an uncalibrated frame, at least not that I've found when you're using auto dark. Actually, that's something I should look into, see if there's a way to change that setting, but I don't think there is. And I apologize if you hear the neighbors behind me tonight. They are watching some sort of sporting event in their back patio area and having a raucous good time over there, so you might hear them cheering occasionally. Oh, you're in the UK, okay. Oh, Raffles. Sorry, I mistook you for Sassafras there. Cloudy and sun coming up in an hour. Hey, Snooch, good to see you. Hey, Mr. Unite. Yeah, we've got a supernova. There it is. So we just got the dark frame in, and now you can see the galaxy much better without all those hot pixels in the way. And it was pointed out last time that there's this bit of color to the supernova. Now, the way CCD Soft handles these color images is not great. It's good enough, but it does produce some artificial color fringing inside the stars. Basically, the reason you were seeing these bright, very colorful pixels is because each pixel is pre-filtered for a particular color, red, green, or blue, in a repeating matrix. That matrix has to be debayered. It goes through a process called debayering, because it's a Bayer matrix. So the program has to do interpolation of the full color image. All consumer cameras that you get do this naturally, unless they're some sort of specialized multi-chip camera or something, or a black and white camera or something. Your typical consumer camera is using this technique, where each pixel is pre-filtered for a particular color, and it's interpolating the full resolution image from a matrix of red, green, and blue pixels. So the algorithm that CCD-Soft uses is honestly not great. It produces this kind of color fringing as an artifact of the processing it does, but it is saving the raw FITS file without any debayering baked in. So the raw data is there in the original matrix of red, green, and blue pixels. I feed that through a different program when I stack the images at the end. Stacking is a process where you average the images together. So I load that into Deep Sky Stacker, and that gives me direct control over which algorithm to use. And so for this, I'll probably use AHD, the AHD algorithm, which is a much higher quality algorithm for going through this debayering process. And you won't see that kind of color fringing, not in this way. You will get color in the stars and around the star, but not in the middle of the star like this, which isn't really how it's supposed to look, I guess you could say. But between what it's doing with stretching the contrast of the image to show you the most important parts of the histogram and the color interpolation it's doing, it results in this kind of artifact. And that's just something I have no control over with CCD-Soft. Yeah, CCD-Soft was really designed for grayscale astronomical cameras, which a lot of amateur astronomers would prefer that. A grayscale camera lets you have higher sensitivity, higher resolution, because every pixel is being used for the same thing at once. So there is no pre-filtered matrix, and you can use it with narrowband color filters to do a Hubble-style color palette and image even under heavily light-polluted skies at very narrow wavelengths. You can also use it with broadband color filters, and when you put each color filter over the camera, every pixel is contributing to that data for that color, as opposed to this kind of setup where, for example, only 1/4 of the pixels are blue pixels, only 1/4 of the pixels are red pixels, and half of the pixels are actually green pixels. It's a repeating matrix of 2 green, 1 red, 1 blue pixel. And so if you are using, say, a narrowband color filter, you can do that, and you can, say, look at hydrogen alpha, which is a very narrow portion of the spectrum. But only the red pixels are then contributing to the final image. And like I just said, they are only 25% of all the pixels. So effectively, you only get 25% of the resolution of a camera that would be grayscale, where none of the pixels have these color filters on them, and all of them can contribute to that data. And so that is why a grayscale camera is generally more valuable than a single-shot color camera. Now, to some extent, that story is maybe changing a little bit with modern amateur astronomy and modern ZWO cameras that are very popular. There are a lot of very popular single-shot color cameras out there these days, but when this camera was made back in the day, early 2000s, the grayscale variant of this camera, they made one, was actually worth a little bit more than this version of the camera for that reason. But fun thing about this camera that I love is the fact that it uses the exact same CCD that's currently being used on a couple of the Mars rovers, Perseverance and Curiosity. Alright, here comes our next image. Nice, nice, looking good. So yeah, the mast cameras on Perseverance and Curiosity use the same CCD chip that's in this camera. It's a KAI 2020 CM, and this particular astronomical camera, the model number is a SBIG ST2000 XCM. super cooled processors. It is cooled. The SBIG cameras, to be honest, aren't as deep cooling as some of their competitors. Finger Lakes Instruments makes some really high quality cameras that can have multi-stage chillers that chill it down to minus 20 Celsius even. I'm only getting -5 now at 72, 75% power. I don't want to push it past about 75% power. I mean, I could, but I don't like running the cooler full out. Plus, you don't have as fine control once you get to the top of the power band on it. You want it to be able to control that set point. You notice it bounces between about -4.8 to -5.2, and that's normal. That's about the dead band that it has. But if I said to command it down to, say, -10 degrees, I could probably get close, but it might not quite get there all the way. And once you get to that 90-95% power level, it has trouble maintaining the set point that you command. It also does have a water cooling option, actually. It's got a port on it, a couple ports on it, so you can flow liquid coolant through the camera, through a radiator inside the camera, so give it some extra cooling. And I could do that, but I've never tried it. I just don't trust. I don't like the idea of running any liquid through my camera. Just the thought of it gives me the heebie-jeebies. I know I probably shouldn't be so paranoid about it, but if it springs a leak or something, well, I just killed the camera. So don't really fancy that idea. But it does have that option if you want some extra cooling. Alright, so I really haven't mentioned it so far in this stream, but this galaxy is about, what did I say, 20 million light years away, I think? Oh. Let's see. Yeah, 23 million light years according to Sky Safari. So we're looking back in time 23 million years. And yes, that means the supernova actually happened millions of years ago, and we're only just now seeing it. In fact, its remnants would have probably started to dissipate by now. But, no, its remnants definitely would have started to dissipate by now, if not fully dissipated by now. But this is a core collapse supernova, so a massive star that ran out of fuel, gravity took over, and collapsed, and then created a supernova reaction. And so, a little bit about supernovas. They are responsible for generating elements heavier than iron on the periodic table. A star can only fuse up to a certain element. In fact, fusion at iron stops being beneficial in terms of a net energy producer. You can fuse elements heavier than iron, but you're not going to get more energy out of it than you put into it. And so this is why you want to fuse very light elements if you're trying to produce power. Say hydrogen, or even more ideally deuterium. You can fuse helium, you can fuse carbon, you can fuse these heavier and heavier elements. But when you get to iron, it's physically impossible to get more energy out of it than you've put into it. It becomes a net energy sucker, if you will, or drain on your reaction. So a star cannot live off of fusing iron and heavier elements. And so in order to get those elements in planets like ours, they had to have come from energetic events like this, like supernovas, where the event is so energetic that it doesn't matter that it takes more energy to fuse elements heavier than iron. The event will cause that to happen. Even if it's a net energy loss. And that will also have the effect of, the explosion will have the effect of scattering those elements out into the interstellar medium, where they can be incorporated into future solar systems, future planets like ours. So, as Carl Sagan said, we are star stuff, and in particular, anything at the iron level or heavier is coming from supernovas, scattering elements into the galaxies. Theodore Daniel has quite a out there belief system, it seems. I don't know why he even brings up gas giants. This isn't a gas giant, but we can learn a lot about these events from spectroscopy. But as far as gas giants go, check some of the earlier videos on my channel. They're not fake. They are quite real. I've got some nice videos of Jupiter and Saturn. You can even see the rotation of Jupiter in some of my time-lapse videos. And in fact, I'm working on a video right now, not about gas giants specifically, but about measuring the scale of the solar system. So that'll be coming soon. It's quite a challenging but fun project that I've been working on for the last several months. Is it going to end in a black hole or a neutron star? Well, it would have created that already. In fact, the supernova event has essentially happened, and we're seeing the light of it and the energy of it. It's so energetic that it's actually outshining the core of the galaxy in terms of brightness, and it will continue to do so for weeks to come. But yes, it would have already created likely either a neutron star or possibly a new black hole in that galaxy. Not a supermassive black hole, mind you, like you would find at the center of a galaxy, but closer to a stellar mass black hole. Do we know how big? Not that I know of. Maybe somebody's figured that out based on the amount of light emitted by this event and the energy of the explosion. There's probably estimates out there, but I don't know off the top of my head, except to say it would not be a supermassive black hole, but it would be something closer to stellar mass type of black hole. Oh yeah, no, I'm happy for you to share it, Sassafras. Thank you. Happy for you to share it. I will say the only caveat is, and I'm sure you already did, but be sure to give people the link back to the stream so they can join and watch. Here comes the next image in just a second. I'm gonna head in actually for a couple minutes and start copying these pictures we've collected so far and just verify that they stack well with the previous night's images. So I will be right back. Stay tuned. I have returned, and just in time for another new image. Now, a few images ago, there was a satellite that passed through. I'm sure you guys saw. You're probably yelling at me in the chat, but let me present you guys with the first stack of the evening, which is actually combining all of the images from the previous live stream with the first 30 minutes of images of tonight's live stream. So the last live stream we got up to 2.5 hours of light. That's what that looked like. The supernova was there. And so this was 2.5 hours of light on that. Turn that off for a second. Okay, so this was, as I said, 2.5 hours from the previous live stream. Now let me pull in the image that I just stacked with 3 hours, 30 minutes of which came from tonight. And the images that we're collecting tonight are of higher quality for two reasons. One, there's no moon out right now, so the background light level is improved for that reason. And two, I've got the camera cooled down to -5 instead of running at 2 degrees Celsius. So another 7 degrees of Celsius of colder temperature does make a difference. Here we go. There is the 3-hour image. And I don't know if you guys can tell on the stream. Why is it trying to output at 7,000 kilobytes a second? I don't know why, but hopefully my stream's working okay. OBS is trying to crank out a whole bunch of data. I don't know why. It's running higher than the set limit I have for the stream, and it's in the red. So I don't know if it's lagging real bad or anything. I hope not. Oh, now it's healthy. I don't know why it was doing that. But nevertheless, I think the 3-hour image here looks significantly better than the 2.5-hour image. 2.5 hour, 3 hour. 2.5 hour, 2.5 hour, 3 hour. The galaxy itself is a little bit brighter. I guess I processed it with the background light level also a little bit brighter, but I think you can see some enhanced definition in the galaxy. Not just because the image is a little bit bigger, but the amount of light collected is a little better. If I take this image and I try to blow it up to be like the other one. Let's see, make that bigger. Okay, now the only difference is the rotation, I think. Yeah, just a little bit rotated. But yeah, you can, if you look, especially in the dim parts of the spirals, there's more definition there than in this image. 3 hours versus 2.5 hours. 3 hours, 2.5 hours. 3 hours. Okay, so I think that's pretty good. I'm pretty happy with how that's coming along. So we'll keep adding light to it. Now I'm going to move these windows around a little bit and reorganize to be able to show people who come in later so they can see the stacked image versus the live image. We'll have that hooked up here. There's the next live image just arrived. Move this camera control window up here. I don't want to move it down that far, but I want to be able to see my guide star, so I'm going to shrink the camera control window a little bit so I can see my guide star clearly. Make sure everything continues to look good with that, and it does. Move this behind the others. Expand that a little bit. There we go. This is now a 3-hour stack, so we'll change this. This is live. Alright, I'm pretty happy with that. Yeah, I agree. I think you can definitely see more three-dimensional structure in those spiral arms now with this 3-hour stack than just the 2.5 hour. I mean, to me, that's pretty impressive that even just a little bit more light, just 30 minutes more light, improved it that much. So I'm really excited to see what another couple hours on top of this will do. Yeah, and I'm not sure how much the brighter looking supernova is contributing from the fact that there's no moon and the camera's running at a colder temperature, so there's less background thermal noise. But it definitely, the whole thing looks brighter to me. The galaxy and everything. The galaxy, even in the live image, is much more detailed than it was whenever it was, over a week ago when I last shot this galaxy. Noise sacrifice for detail. Yeah, I didn't save the exact amount that I adjusted the contrast by from last time, so I just had to take a stab at it tonight, and obviously I did it a little bit differently, but I think I could afford to because there's more data there. Oh yeah, no, I'm going to put it through tone mapping as well. As far as deconvolution, I should do that. I guess I do a little. I guess the tone mapping algorithm I use in Iris does a little bit of deconvolution, but it's not really proper. Especially with adaptive optics, you're supposed to be able to do a lot of deconvolution on the images because they're so well tracked. But yeah, I should consider, I definitely will do some tone mapping, so we'll get high dynamic range out of it. But but I should look into using a deconvolution algorithm as well. I mean, part of my problem is I'm using PixInsight LE Lite Edition. Most people don't even know what that is at this point, but it was a free version of PixInsight before it became a $300 program, and it's definitely more limited. Ooh, another satellite passing through there. I'm betting these are probably Starlinks or something. I'm generally not seeing Oh. No. What are you? What are you? Come here, come here. Hawk C. Hawk C? Hawk C. Might have been Hawk C. I don't know. There was a satellite that just passed by the galaxy a moment ago, according to Sky Safari, that was called Hawk C. That might have been what we're looking at there. Hard to say, but there are Hawk A. Oh, it's a multi-satellite. That was eclipsed. That shouldn't have been it. Oh. Yeah, it should have been an Earth shadow, so that should not have been what we saw there with a streak. There's some iridiums. Another hawk. Yeah, I'm not clear on what that was. But Sky Safari's satellite database is not exhaustive. Could have been a classified satellite. Could have been a random Starlink. I think a lot of the Starlinks are in here, but probably not all of them. Man, the sky is busy though. Orbcom's got some satellites up. Oh, what are you? Oh, here we go. This one was supposed to pass over. Let's see. Yeah, it was supposed to pass over that part of the galaxy. That's got to be it. A few minutes ago, during that last exposure. Yeah. This is our boy. It was actually a rocket booster, an Ariane space rocket booster, launched in 1995 at 858 kilometers. So space junk is the answer. That's what that was. Cool. See, you can't blame Starlink for everything. Sometimes it's not Starlink. Russian severe weather video says, feel free to give a shout out to us. Poor Russians, we got no astro darkness. P.S. There is an AI tool to help you de-bloat, de-noise in that astro tool. I forgot the name of. PPS crickets. Yeah. No, thank you. Appreciate that. I know what you're talking about, and I can't think of the name of it right now. But I have seen that floating around out there. I've been meaning to try that. Maybe I should finally get around to trying that. And $2 from Saskafraz, Canadian. $2.20. Thank you. I just found my new background for my other phone. Well, thank you. Hang on for the final stacked video. The full resolution stack I'll post as a pinned comment on this video once I get all the data in. So stay tuned for that. It's not dim, it's just fast moving. It was actually supposed to be magnitude 4.1 according to Sky Safari, so fairly bright, especially to the telescope. But it's in a relatively low orbit, 858 kilometers, so it would have been moving fast, and didn't stay on any one pixel for very long, because of course I'm tracking the stars here, not the satellite. So it would have shot through the field of view very quickly. There we go, there's our next picture. How hot is it outside? It's pretty warm. It's, gosh, I don't know. According to my phone, 77 degrees out here. 78. Yeah, 78 degrees out here right now. And it feels very muggy, very high humidity tonight. So, not entirely comfortable. What music? This is Stellar Drone. Ah, Russian severe weather videos had their first noctilucent clouds tonight. Nice. Do I know if NASA will replace that noctilucent cloud spotter sat that failed recently? No, I didn't hear about that one. Oh yeah, no, space junk shows up in pictures all the time, even mine, Kaiser Cube. Usually, I mean, I won't say usually, but oftentimes it's not necessarily just a dead rocket booster. Sometimes it's a satellite that was an operational satellite, but oftentimes it's so old it's probably not operational anymore. In this case, though, it's an upper stage of a rocket that is definitely not an operational satellite. It was always space junk. Yeah, magnitude 4.1. It didn't look it, did it? But that's just because of how quickly it's streaked by the galaxy. I mean, in Sky Safari, if I go second by second, it's only over the galaxy in one frame, if you will. 1 second. It was over for much less than a second. But there's only 1 second of time on the clock, if I look at it in Sky Safari, that the satellite was over that part of the galaxy like that. And in the next second, it was clear off the galaxy and much further down the field of view. So it was only in the field of view According to Sky Safari, it went diagonally through the field of view, so it was in there for about the maximum amount of time it could be. For 1, 2, 3, 4 seconds. That's how quickly it streaked through there. And for people's reference, the field of view here, width-wise, is about the size of the full moon. Vertically, less than that. Speaking of vertically, let me see if I can move it up a little bit. Well, okay. Expand it, I guess. Try to get fancy with it here. Again, I still want to see my guide star, but I've got some room up in the top of the frame, so I can afford to pull it up like that. Then we can move our marker like so. How's my anti-dew equipment? Doing okay. I've got a Kendrick dew heater set to 80% on the main aperture right now. Tried to get some pics. SlickX says tried to get some pics of the moon using the phone. Didn't work. Gonna use a webcam instead. Cheap, but should work. Yeah. No, webcams can do a lot, especially if you stack the video from them. Russian Severe says, UMETSAT is putting a sat into service to rival GOES-R. Gonna look amazing at 0.5 kilometer per pixel resolution. Wow, that'll be nice. AIM spacecraft, which monitors noctilucent clouds, may be dead due to problems with onboard bat. Oh, it's a shame. You can get a cell phone telephoto lens from Amazon or Walmart for less than $15 that'll actually give you good pics of the moon. I've never tried those. I've always thought they might be a little bit low quality for my taste, but I mean, hard to argue with the price, I suppose. Can get some good binoculars. Remember when I experimented with astro-modifying my creative IR webcam orb? Oh yeah, those were the days. Yeah. Oh man, and the Logitechs too. I remember when Logitech was like one of the most popular planetary cameras you could get was a Logitech 2U cam, and people would modify those, rip the lens off, and slap it on a telescope. I actually used a cell phone telephoto lens from Walmart and taped a piece of solar glass film to it to record the 2017 solar eclipse. Oh, okay, yeah. That sounds like it would work. Got a moon mode on my cell phone. 600mm Sony lens coupled with a 61 megapixel sensor that can stack to 260 megapixels and a 1000mm APO telescope point at the moon. Sadly, no 5x Barlow. Well, that sounds like some nice equipment anyway. Walmart telephoto for my security cam IR cam. That's funny. Got a monoscope I can use. I just can't remember where I put it. Even got a 1/2-inch thread insert. Well, that's handy. Basically what I'm talking about, just a monoscope with clamps to attach it to a cell phone. Yeah, you can get those. They're basically designed to just clamp onto the cell phone. I'm pretty happy with the Pixel's 4x telephoto on the Pixel 6, Pixel 6 Pro. Not as useful, I'd say, for long exposure deep sky unless you're putting tracking on it, but good to have in the pocket for some quick shots where you want to get something a little bit more up close than you could. Is Red's working on some more tracking and near-Earth observations? I like his stuff, but I'd like to see him work beyond the P1000. Well, I don't know what his current plans are for going beyond the P1000, but he and I are working on a very big video together, and I hope you guys are going to enjoy it. It's something we've been working on together for months, and it's finally all coming together. Got the partial eclipse in 2006 in Moscow on 35mm film held over pocket zoom camera. The pictures in that slice of 35mm is still around. I use it for the recent partial eclipse. Astronomical legacy. There you go. Am I a Jackery guy? Well, that's Red's, actually. He's a Jackery guy. Got one from Amazon. It's a beast of a power supply. Yeah, they're good. If I ever have to get a new one, I'll probably go with a Jackery. I use these big lithium batteries that each have about the capacity of a Jackery, 300 kilowatt hours. And I've got two of them for remote observations. One of them is starting to act up a bit. Well, I don't even know that it's necessarily the battery that's acting up. I guess it is, but you kind of have to fiddle with it to get it to charge. But they're both high-capacity lithium batteries, and I've got voltage regulators for them. One, normally I keep set to the same voltage as my laptop, so I can power the laptop directly without even getting losses from an inverter on it, and it'll power the laptop for hours. And then the other one I use to power the scope and any camera equipment. But it is, they are aging, and they're getting to the point where they don't quite have the oomph to power the scope and the deep space camera that I'm using right now. This thing has a power brick that would rival an Xbox. It's a power hog, honestly, even more than the scope itself. And so trying to run both of them off the one battery on a power inverter, it just doesn't really have the gumption to do it anymore. So eventually I'll have to think about getting a Jackery, but it's not something that's super critical right now, because I do most of my observations from home. And if I'm doing remote observations, it's usually for a rocket launch, and in that case I'm not using this camera. I'm using Black Magic, which is much less of a power hog, and even that is still a battery killer, but it doesn't suck quite as much current as this camera, actually. Stand-up Maths on YouTube made a 1-pixel scope for the Luna eclipse in Australia. The video came out the other day. It's quite interesting. I'll have to check that out. Sounds interesting. Looking forward to that huge Atlas space telescope. Yeah. With JWST's success, I bet the new scope plans will be well funded now. Hope so. If only we as a civilization could last that long. Well, that's a scary thought, isn't it? Used my Powerman 10,000 UPS as a filter and a backup power source in negative 30 Celsius Russian winters, where outlet voltage fluctuates from 180 to 280 volts. P.S. Set your laptop to max power saving and an underclock. Yeah, the laptop is not the problem that I face, because that's on a totally separate battery, and it can run for hours. It's the camera and the telescope, neither one of which I have any option to change their power draw. They're just going to draw what they draw, and those run off the power inverter. But again, it's not really an issue because, especially for deep space observations, I do that from home. And the skies are suitably dark enough for targets like this. I mean, yeah, I could get somewhere even darker, be even better, but there's so much friction involved in trying to do that. I mean, the setup time, the teardown time, trying to do that remote, it's not as much fun. The only exception being Chiefland star parties, which if I'm at Chiefland, then I've got shore power off that anyway, and I can just plug in. So it's not really a consideration for me. And if I'm using remote power, it's because I'm tracking a rocket launch, generally speaking. And for that, this thing works fine. Hey, Mr. Spider, did I tell you you could climb my laptop? I really don't want you building a web on my laptop. I appreciate what you're trying to do there, but no, we're not doing that tonight. Let's get you off. Well, I didn't mean to kill you. I meant to get you off my laptop screen. Come on. Come on. Off. Go build a web somewhere else. Flat Out showed his P1000 yesterday. He's back. Oh, he didn't know that. He's back. Well, I'm glad to hear that. I was hoping he was doing okay. $300 kilowatt hours. Yep. Yeah, the Jackery 240. I think that's the one Reds has, is the 240. Handle all your power needs for 6 hours before it gets to 25%. See, I'd run that down even faster if that had to power literally everything, including my laptop. What is the Bortle in there? I went from 8 to 3, and the difference was notable. Saw Milky Way with my own eyes for the first time. Did I see that aurora outburst recently? I couldn't see it from here. I tried, but the weather wasn't very good anyway. No, I think the spider's still alive. I just got him off the... I thought I killed him at first, but no, he's still running around somewhere. Just not on my screen at the moment. Is it too much to ask not to form a spider web on my laptop screen while I'm using it? But to answer your question about the Bortle, I'm not sure what my Bortle rating is right now. It's probably not as good as I'd like it to be, but better than what I've lived in, generally speaking. Yeah, technically the town I live in is a 6, but I'm on the outskirts, which I'd say I'm actually closer to a Bortle 5. And that's according to the Sky Safari, or not Sky Safari, that's according to a Clear Sky Clock map. Is this anywhere near Cygnus? Not really. This is in Ursa Major. Oh, I'm just realizing. Oh no. All this time. Oh, I'm not happy with myself. I think the adaptive optics is handling it okay, but it did not save my declination setting that I had set earlier in the evening. Okay, well, after this image, I'll change it. Hopefully it's been running okay. I really haven't been paying close attention to the X and Y tilt making sure they're not hitting their limits. Because it does, the adaptive optics unit does command the telescope to move to keep it within the range that the adaptive optics can tilt. The AO does handle all the corrections primarily, but it does need to move the scope to keep it within the range that it can handle. And you need to tell it, normally I cheat by calibrating at the same declination I'm going to be observing at, but there is a setting that you can command it to, or you can tell it what declination you're at, because that's going to influence how hard it needs to move the scope in right ascension to get it to move. And it thinks it's at 0 degrees declination, which is definitely not true. It's actually closer to 50, I think. Yeah, we're at 55. Where are we at? Yeah, 54, roughly. Okay, let me stop imaging for a second. I'm going to set this to 54. And auto guide. Now it's going to take a new dark frame, which is not really what I wanted. That's 5 minutes gone there. Unfortunate, but we did get an hour 10 minutes before I had to interrupt it. And at some point I should also check focus anyway. How soon will we be able to see a nebula from this explosion, you wonder? I mean, who knows with James Webb, maybe they'll get to see that in the next year or two. But I think it's going to be so small at this distance, we're talking 23 million light years, that with an amateur scope that might be quite challenging to see. And yeah, technically I could operate this whole get-up remotely. I mean, I could just go inside and use remote control of the laptop to run the scope and the camera. But where's the fun in that? Besides, this way I can keep an eye on the weather conditions. Right now I am noticing some clouds off to the north. It might be smoke, actually, from the control burns they were doing. Hopefully it doesn't get up too high where it starts to block the galaxy, though. At the moment, we're all good. No sweat, just add another 30 minutes, yeah. Well, you know, when you start to get weather or cloud cover masking the galaxy, you better hope it clears up. Otherwise, you're just adding more light with a higher background light level and kind of degrading the image quality after a certain point. And it's not from Canada, it's from a controlled burn. I'm way down in Florida, so Canada's smoke isn't affecting me at the moment, which is good. But our own local fires are affecting me at the moment, and it was a controlled burn that they were doing around town today, so perfect timing for me, right? They want to make me feel like I'm, you know, in the same boat with everyone else. Now it's going to have to retake the dark frame, I think. No, it's not. What am I thinking? No, I didn't reset the time of the exposure, so it's fine. So it's continuing to use the dark frame, so that's good. So I actually didn't really mess anything up. The interruption in the image taking sequence was pretty darn brief, so that's good. Yeah, it took a long time for the Crab Nebula to expand large enough to see with backyard scopes, and that was inside the Milky Way about 1,000 light years away. The supernova remnant will be very small due to distance. Yeah, it's going to be very small. Now, supernova 1987A, I believe is the designation, was in, I believe, the Large Magellanic Cloud, and that did form a remnant that could be seen with telescopes, but we're talking, professional observatories, I believe. Though, I think with today's level of amateur equipment, which can be quite good in some cases, you might be able to start to see something there. So, if it were closer, I think it'd be possible, but at this distance, at 23 million light years away, I don't think it'll be possible for amateur scopes to really see the nebula forming. Yeah, that's a dust mote, the dark spot. That'll get taken out on the stack with the flat field subtraction. Speaking of which, I should go ahead and run a new stack with the additional images that we now have and see where we're at with things. So I'll be right back. Okay, I'm back with more stacked image goodness. So let me pull it up. We now have 3 hours 45 minutes of light on M101. And I do see some improvement. Again, I'm not sure how well it'll come across on the stream, but this is the new stacked image. And I think that's looking pretty good. Based on the current images, though, compared to other images, eek, that's sized right. I do think it would be worth me readjusting the focus. Now I'll do a quick blink. Okay, so this was 3 hours, and this is now 3 hours 45. So you can see the galaxy is starting to get a little bit brighter compared to the background. 3 hours 45. Now I processed it the exact same way with the exact same sliders on contrast and everything as the previous image. So 3 hours 45. You can definitely see the galaxy is standing out a little more now. So we're making improvements here by doing this. So we'll call this the 3.75 hour stack. And as this picture just completed, I'm going to go ahead and stop the picture taking for a moment, and we'll refocus the scope. So I'm going to double check focus here. I'm going to go to allocate and check on the focus and tighten it up, because I think it could use just a bit of a tweak. About every hour or two, it's good to check with the LX200 and make sure that it's still focused, because you do get mirror flop as the scope rotates and such. Okay, so I'm going to slew the scope over to a bright star to focus on with a focusing mask. Give me just a minute. Okay. Alright, so turn off the marker for the supernova for now. And we're going to do some refocus work. Okay. So yeah, that's what I expected. It's putting targets in the top right corner a little bit, and that's fine. The main thing is that the go-to is consistent in its pointing, so that's good to see. So now I put the focus mask on. That'll generate the diffraction spikes. So you can see the center spike is not quite running through the center of the star, so I was right. We do need to refocus a little bit. We need to get that center spike running right through the center of the star. Did that make it better or worse? I think it made it worse. Okay. have gone too far with it that time. Let's see. No? Okay. Okay, I just tweaked it a little bit. That's looking much better. That's looking much better. I might give it no, I'd say that's actually perfect. I'm going to call that well enough right there. It's dancing around a bit from the atmosphere, but I'd say that's pretty symmetrical right there. I'm going to call that, I don't know, what do you guys think? Should I call that good enough? Maybe I give it just a tiny more. Okay. Okay, I just gave it the most tiny hint of a bump. Yeah, I'm saying that's pretty good right there. Okay. Now we go back to M101. Okay. Now we do this. Go to 3x3 binning for maximum sensitivity. And we reposition the galaxy to get back where we were. Probably about good there. Let's check the auto guider. Yeah, that's good. I'd say that's about where we were when we left off. Go ahead and start the auto guider. Okay. Now we go back to 1x1 binning for full resolution color. We go to 5-minute exposures and we start taking a new picture. Cool. You thought you were OCD with a focus mask. Yeah, no, I'm uber OCD about it. I try to get that thing as pinpoint as I can. I would say it still does give a slightly asymmetrical image, probably due to collimation, but also due to the mask itself. I don't know that the pattern on it is perfect, and I think it presents with one side of the center bar higher than the other, which tickles my OCD in just all the wrong ways, but it is what it is. It's as good as it's gonna get, put it that way. You wish Beetlejuice would blow up already. I don't. I like Beetlejuice. I mean, on the one hand, it would be cool to see. On the other hand, it would change the night sky forever. That's for sure. And I have to say, anytime I've got the camera pointed at Beetlejuice, I'm just a little bit... I know it's silly, because it could blow up any time now, between now and 50,000 years from now. But I'm always just a little bit concerned that it'll blow up right when I'm taking a picture and fry my camera. I don't think the deep space camera could handle it if that happened. And yeah, not right now while it's behind the sun. That would be really bad, because then we can't even see it happening. And you watch, whenever it does happen, that'll probably be when it happens, when it's hidden by the sun and we don't even get to see it. But no, I wonder about, you know, Stereo and other spacecraft like that orbiting elsewhere in the solar system. They might, even in that scenario, they might pick it up before we do. And I'm pretty sure we would see the neutrino emissions. Like, you would suddenly get this neutrino spike going through the Earth, and that would be your clue as to what the heck is happening. Okay, let me reactivate the camera control window view. There you guys go. So you can see we got 108 seconds left on this exposure. And let me put it over on the auto guide screen so we can monitor the adaptive optics working away at keeping that star nice and centered. So we're guiding at 1.9 hertz, looking good. No, I don't think we're in the path of the beam if Beetlejuice blows. Don't want to get the planet fried by a gamma ray burst. That'd be a very bad day. That'd be game over for all of us. Only on the side facing it. Yeah, well, the side facing it gets to go first, but I don't think the side facing away from it survives a whole lot longer after that. Oh yeah, Altaz, yeah. 10-second exposures get star trails. You should really try with the polar. You've got the 4-inch next star, right? Because it's got that built-in stick, as it were, for putting it into a polar aligned configuration. I don't know how well that works with the next star. I haven't tried it personally, other than just for testing. But at least in my experience, like, the LX200 works so much better when it's polar aligned. It was designed to be polar aligned, to be honest. And I suspect that much is the same with the next star, that it would probably behave better when polar aligned, just in general, because then it only has to theoretically move the one motor to keep things in the field of view. So now it's taking a new dark frame since we've reset the camera settings, it's going to refresh the dark frame when we went and redid the focus. So it's got to refresh the dark frame, take a new dark frame, and then we'll be back in business fully. So that's why we got all the hot pixels back on the screen again. While we do that, though, I'm gonna try to get things tweaked here with the window positioning. Crazy thing is snapping. There we go. That's where I want the pointer. Thank you, Kaiser Cube. Now, the colorful pixels, of course, are hot pixels, but you knew that. Smart scopes are overpriced garbage. Well, when it comes to... I hold dim views of the real smart scopes that they make these days, the unistellar scopes and that kind of stuff. I see the attraction of it as a quick, easy way to get into astronomy without having to know what you're doing, without having to know the stars. You know, I look up in the night sky, I know where Regulus is, I know where Denebula is, I know where Arcturus is, Antares, like, I know these stars by name because I use them all the time to align the telescope. You have to know what star you're pointing the telescope at with the LX200. You have to tell it, you're now pointed at this star, and you have to go through that alignment procedure. Even polar aligning. I polar align the scope, I then point it at a second star and sync on that star's position. And then I point it back to Polaris and align the mount, and then I point it back at the star and align the computer. So you have to know the stars to some extent. Celestron scopes do allow you to do smart align, where you point at any three bright objects, doesn't matter what they are, and theoretically it should do you get you in alignment without having to know what they are. But it's really, in my experience, that doesn't work as well as just telling it two stars, doing a two-star manual alignment. But these new scopes, like the Unistellar and stuff, that are like $3,000 for a tiny, tiny telescope that is, it's got smaller, frankly, probably cheaper optics than even an X-Star for a few $100s. But the claim to fame is that you don't have to know what you're doing, essentially. It does it all for you. There's no eyepiece. It's all camera-based. And it's smart, so it, you know, it connects to your tablet, your phone, whatever, and you can control it that way, etc. And it does an automatic out-as alignment using GPS and level sensors and all the rest. Some bigger, frankly, better scopes will do that kind of thing too. But this one is really meant to be simplistic, easy, anyone can use it. And so I see the attraction of that for people who are intimidated by, you know, more complicated hardware. And frankly, they ought to be, in my opinion, starting with something simple like a Dobsonian telescope that you manually point around. I think there's a lot of value in learning how to navigate the sky with a classic star chart and star hop from star to star to get to your target. I learned how to do it that way, you know, on simpler equipment. My first telescope was a little Bushnell refractor. My second telescope was a 6-inch Newtonian on an equatorial mount with a clock drive. Just a mechanical clock drive. It didn't have any kind of go-to capability. You had to manually point it. It was more cumbersome and complicated than a Dobsonian, but once you got on the target, as long as you were polar aligned, which was, I always did just an eyeball alignment, not even as good as what I've done tonight, but once you got it polar aligned, you could flip a switch and the clock drive would turn on and turn the scope and roughly follow the motion of the sky, so you didn't have to keep it centered constantly manually. But you still had to find everything yourself. You were on your own. Viewfinder, eyepieces, all the rest. And, there's a learning curve to that. And so the attraction of these smart scopes is they let you skip the learning curve, in theory. But I think there's value and there's a visceral effect of seeing the planets and even nebulae and galaxies like this through an eyepiece. Now, through an eyepiece, you wouldn't see the color of these stars in this galaxy. Like, it would all look gray and it would look fuzzy and it wouldn't have the kind of detail that we're seeing here because our eyes process the light instantly. And even with a telescope this size, even an 8-inch telescope, even my 11-inch telescope, I'm not going to see color through the eyepiece with my eye. But still, it's still enjoyable, even to me, doing this for many years, to be able to see these objects directly in the eyepiece when I want to. And you don't have that option with a unistellar scope. You can't just put in a physical eyepiece. It's only designed for use with a camera system. Like a certain Chinese-made telescope that I may have reviewed on this channel. And, oh boy, yeah, I've got more stories about that whole experience I'll tell you guys sometime, but maybe get into that later tonight. But the problem with the smart scopes is that they don't offer the option to switch to an eyepiece and view things, visually. You can't do visual observing with them. You do electronically assisted observing, which I think there's a lot of value in, but I don't like that it comes at the expense of not being able to do visual observing, and I certainly don't like the idea that it comes at the expense of $3,000 of equipment. I mean, for that price, you could get this setup. You could get an 8-inch Schmidt Cassegrain and an astronomical CCD camera and go to town and get really high quality pictures, way better than what you can get with one of these smart scopes. But all that said, I get the attraction of having something that is far smaller, more portable, with virtually zero learning curve, and it takes pictures. So yeah, bad Al. I mean, my intention with reviewing that very cheap smart scope, which had no motors, made by a Chinese company, was to show what it could and what it couldn't do. The reality of the situation, because, in the advertisements they might tell you, oh, you can see, brighter nebulae with this. Well, I pointed it at Orion, and you saw what I got. It was basically nothing. I will say I'm still sticking by saying that my expectations were exceeded when it came to the moon. I didn't even think it would do that well. It still had a ton of chromatic aberration. But yeah, okay, if you're got your kids with you, whatever, and you want something that'll hook up to your tablet and get them interested in it from a technology perspective, okay, I can see some degree of value there, but I think it's best tempered with the realization of what it can't do, which is pretty much anything else. And, okay, I'll tell you guys the story, the follow-up to this, that I did not expect. And they didn't tell me that they were going to do this, and I'm still mad about it. So, I released the video after they had to approve it. I couldn't just say whatever I wanted. Though they didn't give me specific outline. Well, they wanted my outline of what I was going to say, and they had to sign off on that. And then they wanted to review the video, and they had to sign off on that. And I was pleasantly surprised that they didn't demand any changes to what I did. But you saw where I couldn't be too harsh, right? I had to be fair and balanced in my review. And like I said, when it comes to the moon, the scope, the little Beaver Lab scope, exceeded my expectations, and because my expectations were in the floor, okay? And they approached me on this matter. I didn't seek them out to do this review, but they asked me, and I said, fine, but I'm going to do it as a review, not as an advertisement. But here's what I really didn't expect. So I released the video when they tell me to, and I don't know, about a week or two later, they email me again, and they asked to see my analytics on the video, and the video was doing terrible on my channel. I didn't expect it to do any better than that, honestly. But again, I was happy to do my little review and my breakdown of this smart scope. So I give them my analytics. I'm like, here you go. What do you want? Here you go. And they're like, thanks. I'm like, that's weird. Why would they ask for that? They wanted a baseline. I'm convinced. Because what happened next, and I've got the screenshots. The video now has, I'm pretty sure, over 1,000 views, unless YouTube took away the views, and YouTube should. Because what happened next was not natural. This was not organic growth. They'd neither told me that they were going to do this, nor would I have allowed them to if they had told me. Yeah, it's got 2,800 views. It had less than 1,000. It had a few hundred when they asked for the analytics in the first week or so. Now it has 2,800 views, and it's a bloody hockey stick. Within one day, it got 1,200 views. Out of nowhere. And where did that traffic come from? Oh, I can see the analytics, guys. I can see the analytics. The traffic came from every other video that had ever been made about this telescope. They were all recommending my video. And I was recommending their videos. Or at least, that seemed to be what was happening. The traffic was crisscrossing between every video about the scope to every other video about this scope. Bots. Oh yeah. They botnetted the heck out of my channel. They botted the views on that video, and I've never seen that activity on my channel before or since. I've never seen anything like it, where in a day, boom, 1,200 views were delivered, whatever, and then it immediately stopped. It was within a few hours of time, basically, and it just goes vertical, and then it levels off. It goes back to organic growth after that. Someone, I won't say who because I don't have proof who did it, but I think we all know, someone purchased bots to view all these videos. They wanted that video up, my review up, by a certain date and a certain time. They were very adamant about that. That's the one thing they were super adamant about. Can you get this video up in like a week? I'm like, yeah, I can do it. And I did. They wanted it up by a certain time. Why? Because they were going, well, I can't say that they definitely did, but my theory is a certain someone wanted to make sure that all these videos were in place so that they could all pass traffic to each other. And I am still mad about that. I did not know they were going to do that. If I had known, I would have never accepted from the beginning, to be honest. And then there's the whole controversy about them dictating the comments left on that video and demanding I take down negative comments on the video. There was no warning about that, though if you read the contract I had to sign to do the review, it's implied that they do get to control my content on my channel. Like, it's a catch-all kind of phrase, but it doesn't say, we will tell you to delete comments if we don't like them. It didn't say that. But they basically, if you read the contract a certain way, yeah, I can see how they have basically planted that kind of control over that video for, I think, a 6-month period, maybe 12 months. There's like a certain time period associated with it, but yes, they can demand I remove comments on that video. Well, you guys know I have a certain Discord channel where I used to have a bot that would run and post comments deleted from various channels, including my own. Mine's the first one listed. Well, you can guess where any deleted comments from my channel are going to go, and have gone. So, if you want to see what they are forcing me to delete, you can. That's all I'll say about that. So, I guess you could call it malicious compliance, yes? Because on the one hand, yeah, I'm complying, but you guys know where you can go and see what I'm having to comply with. Yay! Yeah, and it puts my channel at risk by them doing that. Exactly. Which is why I'm so mad about it. Because, yeah, that puts my channel at risk. If YouTube realizes that, and obviously they haven't because the views are still there, they seem to think they're valid, because it's probably some... You know, you see these pictures of these bot centers where basically they have cheap tablets laid out in rows connected online, and they go around tapping them to generate views, where it's not just a program running. I mean, it's physical hardware. I mean, that's the level that some of these botted views are willing to go to, and so that's probably something like what they did here. Is there a chance I can post said Discord channel? Oh, certainly. Let me see here. I'll post a link to the video describing the bot. Let's see, has this got it? Yes, this has got it. So, the link to the Discord is in the description of this video describing the censorship detection bot that I created years ago. So you can go check that out. Yeah. So, if you go to the Discord server, mine is the first channel listed. It's not set up for people to be able to chat. It's just there to document and archive and record what was deleted off of various channels. Some channels people asked me to monitor, so I threw them in there. But I put mine up at the top, so you can see what comments were deleted off my channel. Generally speaking, in that case, that is kind of a negative control, because during the period of time I was running that, I wasn't deleting any comments, except one case where the guy kept posting and then deleting his own comments, and I eventually had to block him because he was just spamming the channel, because anytime I would try to respond to him, he would delete his own comment to hide my comment, and I was getting sick of that. He was basically trying to censor me so that I couldn't respond to him on my own channel. That was not going to fly. So I eventually blocked him, and that final comment got, you know, thrown on the bot because it was deleted. But other than that, those were comments that either people deleted themselves or YouTube deleted for them because they had their channel banned, deleted, whatever. So sometimes if someone's channel would get deleted or banned, their comments would vanish from all of my videos and suddenly pop up on the bot. And it wasn't that I had done anything, it's that YouTube had done something. So that was kind of interesting to just see that activity getting logged. It was just kind of an interesting experiment for me. But yeah, it also now serves the purpose of capturing anything I am forced to remove. Do I have an Astronomy Live Discord, though? No, I have neither the time nor inclination to moderate any Discord. So, I only use Discord as a convenient way of hosting messages captured by a bot that I created. Discord is super sketchy. Yeah, I mean, the problem is not even necessarily that well, maybe Discord is sketchy, I don't know, I guess I don't follow it that closely, but people on Discord can be very sketchy, and that's the problem. I would have to be able to moderate it, and make sure people aren't posting stuff they shouldn't post, and that kind of thing, or, you know, obviously I've got a lot of moderators on this channel, which I appreciate, and I love you guys for doing that for me, but I don't want to commit people to having to do that as well. It's just, it's a headache that I don't need, is what it is. I got plenty of other stuff going on that I don't need to be doing that. Yeah, some of these fine folks can help me mod. I know, that's true. They could. It's just, there's so much drama, especially in this community for some reason. And by this community, I mean the YouTuber community, streamers, even within the space community. So even within the niche that is space YouTube, there's so much drama that goes on from Discords, and I just don't want any part of it. So again, that's why there's no open chat on my Discord. Like, that's not what that's for. Oh, I'm sure UFO YouTube is way worse. I'm sure it is. But even within the space community, you would think people would be well behaved. No. There's so much stuff, and I mean, some people that slip into this community that are actually really bad and looking for kids, okay? And I'm just not gonna have that. There was someone who to me is a kid, just so much younger than me, but he was apparently trying to find kids who are underage, and yeah, ick, right? He was following me on Twitter until I blocked him once I found out what was going on. Fortunately, I had nothing to do with him, but he was following me on Twitter, and I'm sure he would have been in my Discord if I'd had a Discord. So I don't want any of it. No thank you. Appreciate it. And it's no one here in this chat, obviously, but it's just like, oh. And so all this stuff, like this whole drama situation involving him, a lot of it had to do with Discord, from what I could tell. And like, I was thankful in that moment that I didn't have a Discord where any of that was going on. So thank goodness. It's just something I don't need to deal with. Can I tell you about some of my unexplained encounters with flying stuff? Well, there's not much to say, really. I mean, there was that one partial solar eclipse that I was doing a live stream. Something flew across the sun. I think it was probably balloons coming off a barrier island between me and the Gulf of Mexico. And a few miles away, there was an island between me and the sun, essentially, that balloons could have lifted off from and passed over the sun. No one else watching the eclipse noticed anything, so it had to have been local to me. But I certainly didn't expect it. It freaked me out during the live stream when I saw it right before the eclipse began. Because I didn't expect to see something like that. It was moving way too slow to be a satellite, way too large to be, you know, any satellite other than ISS, which would have crossed the sun in a split second. But again, it was probably a cluster of balloons, to be honest. That's what they want me to think. Yeah, it is probably what they want me to think. You saw a ball of lightning once? I bet that was freaky. I would love to see something like that, but I have not seen that before. I've seen, I mean, much more normal stuff, but I've seen zodiacal light, you know, from Chiefland and that kind of thing. I've seen a satellite that was getting ready to burn up. It burned up in less than one orbit later, and it was flashing real it was freaky if you didn't know what it was and why it was doing it, but it was tumbling very rapidly. And so as it tumbled, it would catch the sun and it would blink. But whereas I've seen plenty of satellites that are flashers that blink like this, it was like a perfect square wave of brightness where it was on, off, on, off, on, off. And it was faster than you would see the lights on a plane normally. And much more consistent, I guess. You'd say, like, you know, if you see strobes on like a plane or a helicopter, there will usually be more than one strobe, and they'll be on slightly different timings. It wasn't like that. It was just one light going on, off, as it moved through the sky. It was almost freaky to see, but again, I knew what I was looking at because I was looking for it, and I knew it would probably be tumbling, and sure enough, it was. And it was the coolest thing. I think it was that UR's? It might have been the UR's satellite, but anyway, it was just really neat to see. You know, I've seen the NOSS satellites flying in formation. I've seen MMS flying in formation. I've seen, you know, multiple groups of satellites, 3 or 4 satellites at a time, flying in formation with each other, either through the telescope or by eye, and that's always cool to see. We still have these clouds hanging out in the north. I'm not sure if that's smoke residual from the control burn or just a cloud front. I can see both sides of it though, but it's kind of directly below and into the Big Dipper, but not up by the handle where M101 is. So we're still okay on M101, but I am concerned that in the next hour or so we're going to start to get clouds over it. And $20 from Kaiser Cube, beer money to celebrate the M101 SN revised stream with better detail. Enjoy the weekend, Astronomy Live. Cheers. Cheers, Kaiser Cube. Thank you. I'll raise a glass to you. Appreciate it. Have myself a little Playlindo Brewery beer with that. Thank you. I've seen constellations of sats in a line getting brighter and dimmer in a wave. Oh, that's another great example. Yeah, Starlink. Seeing Starlink satellites a couple different times have been really, again, would be freaky if I didn't know what I was looking at or expecting it, but I did know what I was looking at and I was expecting it. One time was a couple days after launch, I think, and this was one of the early Starlink satellite launches, and they were still pretty bright reflectors, and they were going overhead over my house, one after the other, but they were far enough apart that they weren't a tight train like you see right after launch, but they were still close enough that they were all within a couple seconds of each other. And so you would just see one satellite, another satellite, another satellite, another satellite coming up and going over, one after the other after the other. And I tracked one of them one time doing that, actually a couple of them one time, because I could go from one satellite to the next with a telescope, and caught them up close enough that you could see the solar array folded out from it through the telescope at high magnification. Really cool. And another time, I was actually at my brother's place in New Mexico and saw a train of Starlink satellites real tight, probably within a day or less after launch. And again, I knew it was going to be passing over, so as soon as I got to his house, I was like, bro, we got to come outside, you got to see this. And we saw it, and it went over. Only time I've seen a Starlink train that tight, that close together, and it was when I was in New Mexico, and it was just brilliant, just beautiful. You know, if you didn't know what you were looking at, you could easily think it was like a long cylindrical UFO or something, you know, with windows looking at you, but it was this train of, 60 or so Starlink satellites. Have I been able to image the Chinese station? No, I have not. To be fair, I haven't made a really strong effort at it, but there are opportunities upcoming this week, this next week, that I might try for at some point with an early morning pass. So we'll see. I'm gonna see what I can do with that. I do wanna image it with a sat tracker. So stay tuned. maybe this upcoming week I'll get a good shot of it, depending on the weather. So you saw them. Oh, they didn't move in the sky. Their skyline seemed stationary. Just a wave of brightness going down that line. Sounds like geostationary satellites. When you get them in eclipse season, what will happen is right before they go into Earth's shadow, the sun is almost directly behind you relative to the geostationary satellite, and they will catch the sun real well off the solar panels and any flat surfaces, and it'll increase in brightness significantly, even to the point that you might see it by eye, right before it goes into the Earth's shadow. So it won't appear to move, but it'll appear to get bright and then dim out. And then the next one in the line of geostationary satellites along the geostationary band will do the same thing. Imagine if I imaged it and it's just one Soyuz module. I'm pretty sure it's not. Other amateurs have definitely imaged it. Friend of mine, Phil, he's done some really good work on it, and he's shown some great detail on it. Lord Philip. Check him out on Twitter, and I think he's on Facebook as well. Let's see. Yeah, I guess it was fine. Here I am messing with it. I shouldn't be messing with it, but wanted to see if I could reposition the picture a little bit. Let's see, what do we got? We got working on image 7 of the new sequence since I refocused. And I think I had 14 images before that, or so, maybe 13. It's probably on image 20 now. It's almost worth me going back inside to do another stack and update the image stack. I think it's worth doing that at this point. Oh yeah, the Three-Body Problem Sci-Fi book. I've heard of that. I have not read it. Is that the one about the dark forest hypothesis? I could be wrong, but it reminds me of this one I heard about that I should read, that is basically the plot is the dark forest hypothesis. And so it wasn't, maybe it wasn't that one, but if it is, then it's not even really about the three-body problem. It's about the dark forest hypothesis, which, oh, dark forest is the second book of the series. Okay, that's what I was thinking of. Then it goes into the dark forest. Okay. Yeah, it's Chinese. I think I heard that. The second book of it is. Okay, yeah. Which that's a really fun, to me anyway, fascinating sort of spooky hypothesis. For those who don't know, the dark forest hypothesis states that the reason we haven't heard aliens with SETI on the radio is because the ones who speak up and can be heard on radio get eaten first, essentially. That the reason the galaxy sounds quiet is because there's a malevolent force, alien civilization, whatever, that if you get noticed, you get killed quickly. And that might not be like Independence Day. It might be something like they just hurtle a rock at your planet at near light speed and obliterate you without even setting foot in your solar system. And to expound upon that further, why would a civilization do that? Well, what if it's a xenophobic civilization that is trying to take a proactive approach, that when they detect a civilization, another alien species that might become intelligent enough to start wandering around the galaxy, might be a threat one day, just snuff it out long before it can even be a threat. Before they become multiplanetary, wipe them out. And I'm not sure how it's done in the book exactly. I haven't read the book, but I'd be interested to see how that series goes. Sorry if I spoiled anything. They made a movie about that already. It's called Supernova. I haven't seen that either. Yeah. In the books, the aliens live in Alpha Centauri. Oh. Yeah. Okay. Interesting. And the 3 stars wreak havoc. I see. Violent species. Yes. It's a good movie? Okay. I'll have to check it out. Is that the one on Netflix, or am I thinking of something else? Yeah, we got talking about sci-fi stories and stuff there, Caleb. Sorry. Not really violent, just desperate. Oh, that's an interesting way of looking at it. It's an old movie, so not Netflix. Okay. Was made in early 2000s. Okay. I don't think I'd seen that one. I'll have to check it out. What movie? Supernova was the movie recommended to me. We were talking about the dark forest hypothesis, and I guess there's been a couple of stories written or made about that. One apparently was a movie called Supernova. I haven't seen it. And the other one is the second book in the series that starts with the 3-body problem. So... Alright, I'm going to head inside for the desktop so I can stack the current series of images we've collected. But I'll be right back with a new stack of images to present, so stand by. Alright, I have returned with more stacked image goodness. So this is now 4.5 hours of light. And let me bring it up here. There it is. There's 4.5 hour stack of M101. This is again combining images from the previous Supernova webcast with tonight's images. So, okay, so this is now 4.5. Let me change the text on this guy. Just keeps getting better. Again, I use the exact same settings as the previous image to process it in PixInsight. So it's an apples to apples comparison, and you can see the galaxy is now even brighter and better defined compared to the previous 3.75 hour stack. So this is 4.5, that's 3.75, that's 3 hours. So 3.75, 4.5. Steadily improving. I love it. Yeah, I'm definitely pushing the LX200, the 8-inch LX200 to its limits here, but it's doing a good job. I'm quite happy with how it's doing. I mean, this is on the classic LX200 mount, nothing fancy. It's really got no business being this good, to be honest. Oh, what did I do with my phone? Did I leave it inside? I'll be right back. Oh, I just realized my mic was off. Sorry. Yeah, so I've been fooling around here because we've got smoke and haze. You might have noticed the most recent picture suddenly got brighter. Yeah, the galaxy is slowly descending in the sky, and the smoke/cloudiness has been moving up the sky in the north, and they've now met. And that's why it suddenly got brighter. I shut off the auto-guiding because it was almost not detecting the guide star at all. And so I increased the exposure time on the guide star up to 0.7 seconds from 0.5. So we're now guiding at 1.4 hertz, which isn't as good. But the star is better resolved now. But if these images come out any brighter than what we just got there, I'm not even going to add them to the stack at that point because they'll just degrade the quality of the stack. So yeah, that's where we're at. We might be done for the night if this keeps up, because that stuff's not been moving very fast, and it's moving in the wrong direction. It's moving towards the galaxy, not away from the galaxy. And it's just slowly meandering over time. It's just kind of spreading out over time. So we might be close to done here, but I am going to shoot a long exposure of the telescope doing its thing, because that's fun. So I'm going to go grab a tripod for my cell phone so I can go do that. So I'll be right back. Okay, so I'm taking some pictures with the cell phone. Of the scope doing its thing. The mist and haze is still there. I mean, it's still in the image. It's still affecting the image quality, but it's not catastrophically bad, I guess. We'll see how it goes. Yeah, it's doing okay. Could be worse. Famous last words, right? Yeah, just think Linus Tech Tip slogan. It'll be fine. It'll be fine. Yeah. Hey, no problem, Andrew. I'm glad you could join us. I wish I had the kind of product placement capability that LTT has, that he just, he'll be in the middle of a video and whip out his $30 water bottle. Hey, don't forget to hydrate, Should start doing stuff like that on my streams. Aw, don't be a hater, Andrew. And now a word from our sponsor. Exactly. Ooh, working on drones? That sounds fun. Oh, and you're the CTO for a startup on it? Oh, that's cool. Congratulations. Hope it works out. Any news on Juice getting antenna working? Oh, yeah. I haven't followed that as closely as I should. I thought they had some good news about that, but I might have misheard, or I only vaguely heard anyway. But hey, I dare say that that last image improved? Is it just me, or did it get better? Maybe we're entering a better clearing here. I'm happy with that. If so, I'll take it. But I am gonna chance it then. I'm Stop auto guiding, stop imaging for a second. We'll reset it in just a second. I'm going to take it back down to 0.5 second auto guiding for better auto guiding quality here. It's still too risky. How about 0.6? Can we do 0.6? Yeah, we can do 0.6. Okay. I'm not sure how much that will help. Goes to 1.6 hertz instead of 1.4. But I'll take what I can get. The more corrections per second, the better. Yeah, how's that focus motor project coming? I haven't touched mine in a while. I need to try a 12 volt servo instead of the 5 volt. Starting to notice some star coma? Is it getting worse? Maybe I need to refocus again. I mean, yeah, we can do that. Now's as good a time to stop and do that as any. I don't know. What do you guys think? I think it looks pretty fine. Famous last words. What do I do? What do I do? Yeah, maybe I let this image finish and then we go do a refocus again. You're being picky? Yeah. Well, now you're making me nervous. Don't do that. Making me nervous. Make me think the focus is getting worse or something. Stay with it. Looks sort of okay on your tablet. Well, you modeled an SBDT switch used with the project because I couldn't find a library with the exact 3D model. Still got to add it to the footprint, though. Can make out the ring. Well, the ring is an artifact of how the CCD software is handling the stars and the color data. Wiring on the bottom of the prototype board is a mess, but it works. Yeah. You guys got me nervous now. I'm going to go check it. I'm going to go inside and do a blink test with the with the latest frames and just make sure I'm not suffering worse focus than I was an hour ago. Yeah, it's all your fault, Kaiser Cube. I'm blaming you. I'm blaming you. Everyone else can blame you too. It's fine. I do want to check it now. I'm neurotic. I don't want to leave it going for another 30 minutes and find out that actually those frames were kind of blurred. How many light years away? About 23 million light years, roughly. Alright, I'll be right back. Okay, I'm convinced the focus is actually fine now, and actually it seems like the cloud stuff is dissipating, so I'm pretty happy about that too. And I went ahead and stacked all the images that I've got so far, and we now have a stack of 5 hours of light. So I'll bring that up and show you guys what that looks like. Oh yeah, that's looking real good. All this is just quick and dirty processing in PixInsight. Same settings as before. Okay. So again, this is 5 hours taken from both nights' webcasts. So we now have an equal contribution from both webcasts. 2.5 hours from the first webcast, 2.5 hours from this webcast. And if I blink to the previous one, that was 270 minutes. Slight improvement to 5 hours. But let's roll it on back. Let's see, do I have... Yeah, this was... Okay, let me roll it on back all the way to... the end of the previous webcast, okay? So... Oh, I've got that one sized wrong. Okay, hang on. Let me size that down. Okay, so this was the previous webcast. Into the previous webcast to our current image. Quite an improvement. That's what you get for double the light. 2.5 hours, 5 hours. Oh yeah, that's quite an improvement. Two and a half hours to 5 hours. And from the first image I stacked in this webcast, which only had 30 minutes of light added onto it, so from 3 hours to 5 hours, this is 3 hours, 5 hours. So you can really see the improvement the last 2 hours have made. Notice how much dimmer and less contrasty the galaxy looks compared to the background from just the 3 hours of light, now at 5 hours of light. Looks like a pinwheel. Yep, it's the pinwheel galaxy. Yeah, way more arm and lane detail. Yeah, absolutely. So I tell you what, I'm gonna go have some more fun editing the stack and processing it with tone mapping and all the rest to see what kind of image we get with more careful processing of the data. So I'll be right back. Alright, I have returned. And I have a tone-mapped version of the 5-hour stack, processed in Iris. And I think it came out pretty well. There we go. Processed with Iris to do some tone mapping. And some denoising in GIMP. I'm pretty happy with that. And once more, let me load the 5-hour stack that I processed quick and dirty in PixInsight just so you can see for comparison. So this was quick and dirty. This is after more careful tone mapping and control of the levels and contrast. Quick and dirty, a little bit faded. You can see the grain in the image a bit more. But after careful processing, that's what you get. Thanks, Kaiser Cube. I'm pretty happy with that. Yeah, literally quick and dirty. Just throw some quick levels adjustment on it and some dynamic background subtraction to get rid of the gradients in the image, and bam, there you go. There's your quick and dirty PixInsight versus this, which is a bit of that with a lot more, with iris-based tone mapping. And honestly, that picture is pretty good to me. I'm pretty convinced this is my best picture of any galaxy I've ever taken with the telescope. The origin of the noise, well, that's just nature of the camera. Thermal noise, even at negative 5 degrees Celsius, you still get thermal noise. You have background light level, just natural in the sky, the sky glow. The sky literally has a bit of glow to it from our atmosphere. It's not very bright, but it's definitely detectable at this level. On top of that, you got some light pollution, occasional clouds, which have dissipated, thank goodness. But all of that contributes to background light level. And then you have just random noise of the camera trying to detect that very, very faint light. And we're averaging, a bunch of images here from 5 hours worth of images, but still you end up with a not completely smooth background. That's a great question, Whiskey Sadie. Do all galaxies spiral clockwise? I don't believe so. And there's no particular reason for any galaxy to be facing us a particular direction. And there's no up and down in space, of course, so what if we were on the other side of this galaxy looking at it the other way? It would look the opposite direction. Also, it's important to note, and I forgot to mention this earlier, that this image is actually inverted. The telescope is actually inverting the image from the mirror used for the adaptive optics. So in truth, it looks like this. Oh, it didn't do it. Alright, let me try that again. One more time. It looks like this. There we go. That's what the galaxy actually looks like. So now it's spiraling counterclockwise. And that's actually the correct orientation of the galaxy. That's what it really looks like if you could see it like this with your eyes. Also worth noting, this is a true color image. You know, this is a single shot color camera, but it's in true color, with the exception of the fact that the camera is also sensitive into infrared and UV, broader than our eyes are sensitive to. There's no UV or IR filter on the camera in this configuration. It's just accepting whatever light it can, and the window to the CCD chamber is actually quartz. I believe it's a quartz window. It's not just regular glass, so it will let in a broader spectrum of light than a typical window or glass window would. So ultimately, once I get all these images and process the final version, that will be posted to a pinned comment on this video, the recording of this video later. Yeah, glass blocks IR pretty effectively. So that's why they use quartz, I believe, for these cameras. Uses quartz to do beam compression. Interesting. Russian severe weather videos I see commented on the beaver scope. Yeah. Oh, I wonder if they'll pick up on the sarcasm there. I don't think they will. Ooh, you have a spectrometer you can't use? Yeah, I'm kind of interested in that. And yeah, through spectroscopy we could determine the classification. This actually is a core collapse type 2 supernova. Well, that's interesting. I mean, I'm not sure what I would use for it around the house, but I mean, could always donate it to my employer. we use those around the lab, obviously, so yeah. Yeah, spectroscopy, as Kaiser keeps said, spectroscopy has already confirmed it's a type 2 core collapse supernova. My favorite kind. Dr. Tolian Soren's favorite kind. Yeah, it's coming up on 2 o'clock here. So, okay, thanks, Andrew. Appreciate it. Yeah, being a fire in which we all burn, it sure is. I see you got the reference there. I would expect nothing less. So I'm gonna check on what the total image stack time duration is. Once we hit 6 hours on the stack, I'm gonna call it a night. So let me see what we've got. I'll be right back. Alright, so we were at 5 hours 45 minutes before that last image just came in, so we're now at 5 hours 50 minutes. So 2 more pictures, including this one, and then we'll start wrapping up, and we'll have 6 hours of light for me to stack and post the final picture later. Once we get to the point where I'm wrapping up, I'm going to point it over to a DirecTV geostationary satellite, because I promised to do that a while back. and let you guys look at that while I power off the scope and start tearing things down. And yeah, thanks Kaiser Cube. Anyone who hasn't already, please consider hitting that like button. And if you like what you see here, please consider subscribing. A little more than half my viewership comes from people who aren't subscribed. So if you haven't subscribed already, please consider it. Thanks, Beaver. Appreciate the like. So yeah, I'll also look at potentially doing a pair of stacks in addition to the combination of both nights, so you can see the difference. But there's a lot of variables at play there. For one thing, the first night that we did this live stream looking at the supernova, I had to run the camera warm relative to this, so it's not directly comparable from that perspective. Plus there was a lot of moonlight that also degraded the quality of the view. And I think there might have been some haze that night as well. Some cloudiness that I was dealing with, and I kind of had to pick the best frames. So on the whole, there were a lot of variables at play that make it difficult to directly compare them just by eyeballing it. But nevertheless, I would like to do that because we have 2.5 hours of light from that first night that I used before, and we now have more than that on this night, so I would restrict that comparison to 2.5 hours from each night, just so that it's somewhat apples to apples, even though it's not really directly comparable. But I think it would make a nice, interesting comparison just to see how the supernova has changed in brightness. Okay, looking good. one more picture. This will be the last one we get of the supernova. And then we'll move over to a DirecTV satellite and watch a geostationary satellite against the stars for a few minutes. Basically, once we get to the geostationary satellite and I confirm it's there, I'll shut off the drive and you'll see it come to a stop. And I won't need to track or anything. It'll just sit there. Yeah, it's still really bright, and the supernova is still really bright, and it will continue to be bright for the next few weeks, I imagine. A Type 2 supernova like this sticks around for a bit, that's for sure. And it's been a while since we've had one in a galaxy this close. 23 million light years really isn't that far away as galaxies go. There's a Type 1A in M101 just 10 years ago. Interesting. White dwarf, brown dwarf, neutron star now. Either a neutron star or a black hole. That's what this would have become. Quite possibly a black hole. Here we go. Coming up on the last image of the night for the galaxy with the supernova. Alright, exposure complete. And the image is down. Perfect. Oh, 11 years ago, not 10. Okay. I hadn't kept track. let's see. Got to pull up the coordinates for the DirecTV sat. It's going to be DirecTV 8. Hopefully it's in the clear. And it should be in a formation of 3 satellites: Onyx F3, EchoStar 14, and then DirecTV. I'm still tracking. But I will be shutting that off momentarily. Oh. Got 2 satellites there. Okay, I'm going to jump ahead to the next position here. I'm going to try to get ahead of the satellites a little bit because I want to be able to see all 3 and make sure I got all 3 here. I got 2 of them. Okay, hang on. Okay, let's see if we can get the third one. Now, DirecTV should be the one that's bringing up the rear on the three of them. There's the three of them. Okay. Okay. I'm going to move it back a little bit so I don't have the one right at the edge of the view. I shut it off almost too late. Okay, that was too much. Bring it back, bring it back. Alright, sweet. So, again, from left to right, we have geostationary satellite ONIC F3, EchoStar 14, and DirecTV 8. DirecTV 8 was launched in 2005. EchoStar 14 launched in 2010. And ONIC F3 launched in 2007. So if you get your TV from DirecTV 8, that satellite on the right, that dot that's not moving, that is the source of your TV. At this point, I can literally shut the telescope off and they'll stay there. I've set it into land mode so the motors aren't turning, though the controller is still on, so I can move it if I need to. But with that, the telescope is officially off. You might see a little bump there in the star trails. I think you can see it there. But, yeah, scope's off now. And I'm going to start tearing down a little bit. Start putting things away. But, thank you all for coming again. And thank you all for watching. So, again, I'll post the stacked photo as a pinned comment on this recording later, and I'll post it to Twitter as well. But until next time, thanks for watching, and clear skies.